So now let's try to take the derivative of a function, a quotient, that's slightly more complicated than the ones we've seen so far. So here we have the derivative with respect to x of x to the fourth times e to the x in the top and 7x squared minus 1 in the bottom. Now the reason this problem is a little bit more complicated than the last ones we looked at is because the numerator in this case is actually the product of two functions. So when we have to take the derivative of the numerator, we're going to have to use the product rule to do that. And so out to the side here, I've just written down the quotient rule and the product rule to reference. So let's go ahead and jump in. This is a product. We have x to the fourth e to the x in the top and 7x squared minus 1 in the bottom. So I need to use the product rule. So this equals then, if I look at the product rule, I've got g of x f prime of x. So that's the bottom times the derivative of the top. In my case, that's going to be the bottom, 7x squared minus 1 times the derivative of the top, x to the fourth times e to the x. Then minus the top times the derivative of the bottom. So x to the fourth e to the x times the derivative of 7x squared minus 1. And then that's all over the bottom squared. So all over the quantity 7x squared minus 1 squared. Alright, so we have a good bit more work to do in the numerator. Let's work out all these derivatives. So 7x squared minus 1 just stays as is, but now we have the derivative of x to the fourth times e to the x. So this is the product of two functions, and thus I need to use the product rule to take its derivative. Okay, so I'm going to put this in big brackets here. So let's use the product rule on x to the fourth e to the x. So my product rule here says f prime of x g of x. So the derivative of my first piece, so that's the derivative of x to the fourth in my case, times the second piece, times e to the x, plus the first piece, x to the fourth, times the derivative of the second piece. Okay, and that's all in my big brackets, and we'll come back to that once again and do another round of derivatives. But as far as the rest of the numerator goes, I've got x to the fourth e to the x times the derivative of 7x squared minus 1. So the derivative of 7x squared, I'm going to bring down that 2 and it's going to multiply with the 7 to give me 14x. And then that'll just be minus 0. So just 14x. And then I still just have the same thing in the denominator, 7x squared minus 1, quantity squared. Okay, so let's give the numerator another round of work. So 7x squared minus 1 still hanging out front. Okay, let's work a little one here. Now I've got the derivative of x to the fourth. That's a simple power rule, so that's going to give me 4x cubed times e to the x plus x to the fourth times e to the x. Okay, so not so bad after all inside those brackets. And then minus x to the fourth e to the x times 14x. And actually, let me back up one step. I meant to just go ahead and simplify this last term. X to the fourth times e to the x times 14x. Now the 14 is just a constant, but what I can combine is that x to the fourth times x, and just write it as x to the fifth, e to the x. And then this is all over 7x squared minus 1 quantity squared. Now I'm going to stop at this point. There is a good bit of simplification work that could be done here if you needed to or were required to for whatever reason. But that could take quite a bit of time, so I'm going to stop here. Just know that if you did want to simplify this, you'd just basically be factoring things out, FOILing things out, combining terms in that numerator to try and get it a little condensed. But this shows you how to use both the quotient rule and the product rule in conjunction to take a derivative.